You know, every time you use an app or a website, there's a hidden battle being fought, deep inside a server somewhere. It's a fight over how your data gets stored, and the outcome of that fight is the difference between an app that's lightning fast and one that's painfully slow.
So, let's start with something that looks, well, pretty simple, right? A totally standard table of employee data. You got names, you got IDs, salaries, it all seems completely straightforward.
But here's the real question. What happens when a computer needs to save this to a physical disk? I mean, it's not like it's taken a screenshot of a spreadsheet. It has to physically lay out all that data, bit by bit. And how it decides to do that, well, that changes absolutely everything. And it turns out, for this one simple problem, there are two fundamentally different philosophies for how to tackle it. Two completely opposing schools of thought for organizing the exact same information.
This right here is the fork in the road. Do you take all the information about one single employee and bundle it all up together? That's a row. Or do you take the same type of information, like every single first name from all the employees, and group that together? That's a column.
Okay, first, let's go down what's probably the most common and intuitive path, the world of row-oriented databases. This is likely how your brain already thinks about data.
The idea is pretty simple. You take one person, say John Smith, and all his data, his ID, first name, last name, salary, it's all written one right after the other in a single continuous chunk on the disk. The entire record is treated as one single unit.
So on the actual physical disk, this is kind of what it looks like. Computers read and write data in chunks called blocks. A single block might have John Smith's complete record right next to Carrie White's complete record, and so on. But here's the catch. If you only need John's salary, you have no choice but to read his entire row, and maybe Carrie's too, just to get that one little piece of info.
But what if we took that other path? Let's dive into the world of column-oriented databases. And just a heads up, this approach, it flips the entire model on its head.
See here, instead of grouping by person, you group by the type of data. All the first names get stored together in one chunk on the disk. All the social security numbers get stored in another chunk, and all the salaries in a third.
The result is a completely different structure. You don't really have records in the same way anymore. What you have are these distinct lists, a list of all the first names, a list of all the SSNs, and so on, with each list stored separately on the disk.
Okay, so we have our two contenders, Team Row and Team Column. Now it's time to see which one actually performs better. We're going to run 3 different kinds of queries and see who wins the great query race. And to keep it fair, no special indexes. We're talking about raw storage performance.
Our first test is pretty straightforward. Find the first name of the employee with social security number 666. We're basically searching with one column to get data from another. So the RowBased database gets to work. It starts scanning, it reads the first block, full records for John and Carrie, no match. It reads the second block, still no match. Finally, it gets to the third block, finds SSN 666, and pulls out the name Jan. But think about it. To do that, it had to read through a ton of data it didn't even need, like join dates and job titles. The column store, on the other hand, is surgical. It goes directly to the SSN column file and scans only that data. It finds 666, notes its internal position is 106, then it just jumps straight over to the first name column file and grabs the 106th value, which is Jan. It never even glanced at the salary data. That is a clear, decisive win for the column store.
All right, on to round 2. The query this time is, fetch the entire record for the employee with ID number 1. This is something you do all the time, like when an app needs to load a user's complete profile page. And now, oh, how the tables have turned. The RowBased store absolutely shines here. It finds the one block that contains ID 1, and bam, all the data, name, SSN, salary, everything, it's all right there together in one single cheap read from the disk. This is its superpower. The column store, though, is facing a complete nightmare. To piece together that one employee's record, it has to do a separate disk read for every single column. It has to jump to the ID file, then jump to the first name file, then the last name file, and so on. As the source material so memorably puts it, every disk operation, or I/O, kills a duck. And let me tell you, this query kills a lot of ducks. Okay, final round.
a classic analytics query. Calculate the sum of all the salaries in the employee table. We need to look at just one piece of data, but we have to do it across every single record.
The RowBased store has to just trudge through the entire table. It reads every single block, and for each full employee record, it has to pull out the salary and then just discard everything else. It is an incredible amount of wasted reading just to perform one simple calculation.
And this is where the column store reveals its own superpower. It goes straight to the salary column file and just reads that one continuous stream of numbers. That's it. It's unbelievably efficient. Plus, and this is a huge bonus, because all the data is the same type, just numbers, it can be compressed incredibly well, making that read even faster.
So after that race, what did we learn? It's time to translate these results into the real world and figure out when, exactly, you'd use each of these powerful tools.
Okay, here's the crucial takeaway. Row-oriented databases are perfect for what we call transactional systems, or OLTP. Think banking apps, e-commerce sites, places where you're constantly working with one full record at a time. Column-oriented databases are built for analytical systems, or OLAP. Think data warehouses or business dashboards, where you're running massive calculations, but only on a few columns at a time.
So in the end, there is no winner. You wouldn't use a race car to haul lumber, and you wouldn't use a dump truck to win a Grand Prix. It's all about matching the architecture to the specific workload you have.
And that leaves us with a final thought. The software you use every single day, from social media to your company's analytics tools, is built on one of these two philosophies. It's making a choice between rows and columns with every single click. Now that you know the difference, are you sure it's always making the right one?